We've defined slope to be the ratio of the rise to the run, and so we want to be able to now transfer that into a coordinate plane context. So if we suppose that we have some sort of a line or linear surface here in the coordinate plane, then we'll be able to find the slope of this line by finding the ratio of the rise to the run. So it'd be convenient for us to have a couple of ordered pairs that are known on this. And so if we suppose, just for example, that that first ordered pair has coordinates 4, 3, and this other one here is going to have coordinates 12, 9, then to be able to find the slope of this line, we can find the slope just between those couple of different points. So what we'll need to, of course, find the amount of rise that there is between those two particular ordered pairs, and then also find the amount of run. And so, because this right here is at a height of 9, and down here this is a height of 3, then we know there's a distance of 6 between, so that tells us that the rise is going to be 6 units of measure. And then because we've got an x-coordinate of 4 and an x-coordinate of 12, and the distance between 4 and 12 is 8, then our run is going to be 8 units. And so from that then, we're able to determine the slope of this line. So the slope will be equal to the ratio of 6 units of rise to 8 units of run. So you can, of course, reduce that down to 3/4 or 0.75, however you want to express it. So what I want us to be able to take away from this is understand that we're actually able to calculate slope given two ordered pairs that are on the line, and actually using those direct coordinates themselves. And so you'll recognize that because in order to determine this rise here of 6, we were finding the change between this 9 and the 3, which is really finding the change between those particular y coordinates right there. And so we're actually able to determine slope by taking the change in those y coordinates, so the difference between them, and then you'll also recognize that to determine this amount of run right there of 8, that was coming from taking the change in those x coordinates right there of 12 and 4. And so we can write kind of on the bottom right here that this is 12 minus 4. So we want to be able to generalize this not just to the order pairs 4, 3 and 12, 9, but to any sort of xy points. So if instead of 4, 3, this was just x comma y, so any sort of ordered pair. And then same thing for 12, 9, if this was another ordered pair x comma y. Now, because I called both of those points x and y, that doesn't really work because this x is clearly not necessarily going to be the same as that x. So I kind of need to have some different sort of variables. So what I could do is I could label these x and y, or the first x and y as like x sub 1 and then y sub 1. And then I can call this one x sub 2 and then y sub 2. And then what you'll see then is then to determine the slope, if I was doing y2 minus y1 per se, then I would have to start with the x where I started with the first y and then subtract the other x from that. And so what we actually really did is we did just take y2 minus y1 and then divide it by x2 minus x1. And really what we're doing right there is we're just finding the change in the y's and the change in the x's, because that ultimately gives you the rise and the run. So that allows us to define slope in terms of a coordinate plane. So we know that slope can be represented with the variable m, which equals slope, and we know that it is the ratio of the rise to the run, or as we've also expressed, it's the amount of vertical change divided by the amount of horizontal change between two particular points on a line. But what we've just seen now here is if there are 2 points, x sub 1, y sub 1, and x sub 2 and y sub 2 on the line, then we can take y sub 2 minus y sub 1 over x sub 2 minus x sub 1 to be able to find the slope given a couple of ordered pairs. And so really what that means is this is actually the amount of change in the y coordinates, because that's the rise over the change in x. And there is a Greek letter. It looks like a triangle, but that's actually a Greek letter. It's the Greek letter delta, which in math stands for change. And so oftentimes you'll see this as well in terms of defining slope, that we define it as like the change in y over the change in x.